Welcome to the project demonstration of gesture control lamp dimmer. So here we are going to control the intensity of DC lights by providing the gesture inputs, and that will be identified by this MEMS accelerometer ADXL 335. So based on the tilting angle, so when you bend the hand in forward motion, then it will indicate it as a decrement for the intensity of these LEDs. So that will be achieved by this transistor board. And here when you want to increase the intensity of these LEDs, then we should bend this hand in the backward direction, means increments and decrements. So the data will be given as input to this RF encoder HT12E, and from there to the data will be encoded and transmitted through this 433 MHz RF transmitter. The same data will be received by this RF receiver module here, and after that the data will be given for the decoder HT12D. So the decode data will be converted into the 4-bit mode. So here we are transmitting the 4-bit mode data, and the receiver also 4-bit mode data will be given as input to the B0 to B4 pin of our PIC16F72 microcontroller. So here the data is nothing but, so when you are want to decrease the intensity of these LEDs, so then when you bend that, so one data bit will be sent as high. For consider we are using only D0, D1 data bits for this HT12E encoder IC. So D0 is on and its normal condition all are zeros, and D1 is on. So in this manner we are going to inform to the microcontroller through this decoder IC, and the microcontroller is programmed in such a way that when the D0, nothing but D0 received the high, then we should keep on decrease the intensity. So that will be presented with the help of this red LED. So when it is on, so we can know that the so-called decrement operation is execution continuously. Same increment also. When it is off, so there we reach the maximum level or minimum level while decrementing. So the whole system getting power supply from this 230 volts AC transformer. So it's easy to step down the 230 volts AC to 12 volts AC, and from there that was the input to this regulated power supply board. So on this we have the 3 stages. One is the rectifier. With the help of these 4 diodes, we are going to convert the 12 volts AC to 12 volts pulsating DC, and after that we are using a 1000 microfarad capacitor, so we will get the pure DC voltage. So here the DC voltage 12 volts will given as a power supply input to this LEDs, so through this green and yellow cable to this transistor board. And after that we are using 7805 regulator, as we need 5 volts power supply for the microcontroller to make it run. It's an operating voltage. So the 7805 will take 12 volts DC input and provide us a 5 volts constant DC output. So once we provided that, the controller will start reading input from the RF decoder, and based on the signal we are going to provide the pulse width modulation duty cycle to this transistor BC547. As you know, the transistor will act as a switch here. So we are placing this as a switch between this 12 volts power supply and this LEDs. So the on-off signals will be getting from the microcontroller from the PWM pin, that is C2. So while if you want to increase the intensity of these LEDs, so we need to increase the on time. Parallelly the off time will be decreases. So when you want to increase decrease the intensity, then we should decrease the on time. Parallelly off time will be increases. So that parallelly we are going to control the intensity of this DC load. So mount the glove on your hand. So this is a main power source input for the transmitter end. So here we are using LM358 comparators, which will take the input from this MEMS accelerometer. So we are going to provide the x-axis inputs, so decrements and increments. So before on this transmitter, we need to provide the power supply to the receiver section first of all. Then this light will be on and off 2 times. So this is a minimum intensity when we on the kit. And so there we have the 2 LEDs. So decrement LED on and increment LED on. Remaining all are X and other Y axis. So those we are not going to use in our project. So now see. So when I am trying to decrement the intensity, so we now observe the intensity of this LEDs is decreasing and light is off. Now it reaches the least level of this intensity, and when you want to increment, so its maximum is going to be 15 steps. We are going to control the intensity for this DC LEDs. As operating voltage, as we discussed initially, is 12 volts operating voltage. it's a maximum intensity reached by the microcontroller while intensity increasing. Same for the intensity decreasing also. So the distance from the transmitter to receiver is 10 meters minimum and 30 meters maximum. When it is open area, so it will work for maximum of 30 meters. If the cloud is like the persons or humans are present between these two, then the walls, due to that the loss will be occurred and the distance will be decreases to 10 meters.